The ocean at dawn, vast and unforgiving. Here, engineering meets its greatest challenge. To conquer the depths of the abyss. Mapping the ocean floor requires precision. Advanced sonar systems reveal a hidden world. Deep beneath the surface, the survey continues. This 100-meter steel pile is being lifted. Massive hydraulic tension defies the ocean's fury. Precision engineering at the edge of the world.
At these depths, standard construction methods are impossible. Massive hydraulic hammers drive giant steel piles. This anchors the world's largest offshore structures.
Hold that line steady!
Securing these cables requires absolute precision.
Locked and loaded!
Precise monitoring ensures steel deep into the... This is engineering on a colossal scale.
Deep beneath the surface, high-strength grout is pumped directly into the pile's base. This critical process secures the massive foundation.
At the heart of the direct offshore grid, massive steel piles are driven deep into the seabed. Each cylindrical structure must withstand extreme forces. At these extreme depths, precision is non-negotiable. Automated sensors check alignment to the nearest millimeter. Precision is paramount in this deep-sea environment. The massive structure meets its foundation. Precision at these depths is non-negotiable. Every weld must withstand extreme pressure. At 200 miles from the mainland, a new industrial titan is rising. Precision is everything. At sea, isolated from the coast, isolated from the grid, engineers face their greatest challenge yet, casting massive, modular concrete. To secure the foundation, engineers must defy the ocean. These high-tech pumps extract millions of gallons of seawater, creating a dry, safe environment for construction. Reaching hundreds of feet into the abyss, these massive pillars anchor the entire structure. Rising from the depths, these colossal structures defy the ocean's fury, a triumph of modern engineering. To withstand the harsh realities of the deep sea, a specialized anti-corrosion layer is applied, ensuring absolute structural integrity. To conquer the depths, engineers must push the limits. These massive piers extend far into the unforgiving ocean. At the edge of the industrial world, engineering meets the abyss. Massive tunnel segment finally arrives at the site. Floating on the surface, it spans over 200 meters. This is high-stakes, deep-sea engineering at its peak. This is precision engineering on a massive scale. A fleet of tugs must guide the 20,000-ton block. Every movement is calculated to the millimeter. Engineers lower the 50,000-ton structure. Precision is vital at this depth. The foundation of the world's longest tunnel is laid.
Guiding a massive structure requires absolute precision. Every movement is calculated against the ocean's immense power. This is the critical moment of placement.
At these depths, precision is non-negotiable. Massive hydraulic joints begin to lock, securing the tunnel against the abyss.
Initiate final seal on bulkhead Bravo. Copy that. Hydraulics engaging now.
To overcome the open ocean, engineers built a massive artificial island where the bridge suddenly vanishes beneath the sea.
Here, the bridge terminates, plunging directly beneath the ocean, must withstand thousands of tons of water pressure. Directing traffic into the abyss requires absolute precision.
Deep beneath the ocean floor, a network of light awakens. The center of this vast expanse lies a marvel of modern engineering, a man-made island serving as the gateway to a subsea tunnel. To withstand the
Easy does it. Steady on the winches. Steady on the winches.
These depths, every link is pushed to its absolute limit. Thousands of tons of steel fighting against the ocean's grip. This is precision engineering on a colossal scale. Fitting a massive piece requires absolute precision.
Steady on the left. Hold it right there.
To secure the massive deck modules, engineers utilize giant steel bolts. Each fastener must withstand thousands of tons of pressure. Hydraulic wrenches tighten.
On the edge of the human frontier, a monster of steel takes shape over the waves. This is the steel serpent.
Inside this deep-sea simulation hyperlab, this massive tensioner exerts pure brute force, pushing this superalloy cable to its absolute breaking point. At these depths, every kilonewton of pressure is critical. The strain gauges monitor real-time structural tension. Buffeted by gale-force winds, the deck begins to sway. Tremendous stress builds within the steel. Massive hydraulic dampers engage to absorb. Stability is finally restored. Spanning the abyss, this marvel of modern engineering conquers the relentless fury of the deep ocean, a testament to human ingenuity, redefining connectivity. This is the final, critical phase of the project. Paving the deck demands absolute precision, while global trade continues uninterrupted below. Engineering at these depths requires absolute precision. These high-intensity lights are the guardians of the sea. At this scale, every connection must withstand extreme forces. Beneath the deck lies a hidden world of heavy steel. Years of intense engineering lead to this moment. Heavy trucks begin the first historic crossing, testing the strength of this megastructure, a triumph over the deep sea. To conquer the strait, engineers built a megastructure. But the real challenge lies beneath the waves. Tunnel, submerged in the deep abyss. 1,000 meters below the surface, precision engineering meets the abyss. This tunnel represents a triumph of modern design, stretching the limits of human achievement. Spanning across the deep blue expanse lies a miracle of modern engineering. Forging a path beneath the ocean. Rising above the most hostile wild waters on Earth, this megastructure stands as a triumph of modern engineering, pushing the absolute boundaries of architectural design.